Good afternoon, students. Today we are going to discuss about similarity measures. So it's a topic of third unit. So before discussing about the measures directly, first I want to discuss that where exactly the similarity measures play a great role. So we will discuss first about the clustering and then we'll talk about the similarity measures. So with the name clustering or a cluster, you can understand what exactly it is. Clustering is nothing but grouping together certain things. It's called cluster. Suppose I have a basket which consisting of fruits, and I'm asking you to make a cluster of apple, orange, and banana. So you will segregate apple, orange, and banana and you'll make a form a cluster. This is one example of forming a cluster. The second, you can take a simple example like I have a certain students and I want to segregate those students. I want to make a separate cluster for those 60 students, and I'm saying the students who are having 60 to 70%, they'll be in one cluster. The students who are having 70 to 80%, they'll be in another cluster. And students who are having more than 80%, they belongs to third cluster. So this is the basic concept of cluster, and the cluster concept is also used in machine learning also. Okay, so we have some certain algorithms which we are using for forming a cluster in machine learning. So clustering is nothing but it consisting of grouping certain objects that are similar to each other, and it can be used to decide that if two items are similar or they are dissimilar in their properties, they belongs to same category or they does not belong to same category. If they belongs to same category, they will fall into one cluster. It does not belong to same category, they'll be other cluster. So what is our main agenda here? If I'm saying there are two clusters, if there are two clusters, so their distance between these two clusters should be distance within the cluster should be less. Means whatever data points are available in a single cluster, the distance between those two data points should be less. And it means if the distance between two data points are less, which belongs to the same cluster, it means there is a high degree of similarity between the objects or the points which is belongs to that particular cluster. Understood? So the similarity is, we can say, it's a subjective and it depends heavily on the context of the application. So similarity could be of any type: similarity between the features, similarity between the shape, similarity in the color. Suppose I have a apple and strawberry, both are having same color, but their shape is different, their size is different, so they cannot belong to the same cluster, definitely. So it depends on what type of data we are taking. According to that, we have to identify what type of similarity we are looking for. Clear? So this is the view. This is what exactly the clustering. Now, to form a cluster, I have to find out the distance between the two objects or two data points, or I have to see the similarity or dissimilarity between the pair of objects or pair of the points which is available in my data set. So to get the distance between objects or two objects, we are having certain similarity measures are available with us. Generally, in machine learning, we are using these similarity measures, which are as follows: Euclidean distance, Manhattan, Jacob, Minkowski, and cosine index. So one by one, we will discuss all these distance measure techniques. So I hope it is clear what is cluster. So we discuss about the cluster. We know the cluster is nothing but the data item which belongs to the same category or the data points which are similar to each other. They are called as cluster. And to identify that they belong to same cluster or not, I have to find the distance between the data points. To get the distance between the data points, we have different similarity measure techniques which are written here. So now one by one, we will discuss all the similarity measures techniques. So my first method is Euclidean distance. So Euclidean distance is a traditional method which you have studied in your school days also. I hope you have studied this Euclidean distance. So what exactly Euclidean distance is? It's a simple measure, we can say, which is used to find the ordinary distance between the two data points. So if I want to find the ordinary distance between the two data points, I can go with the Euclidean distance. Okay, so in most of the algorithm are using Euclidean distance for forming a cluster. So when we studied about k-mean algorithm, we used Euclidean distance. If you remember, k-mean algorithm will use Euclidean distance to find the distance between the two data points. So what exactly the Euclidean distance work? Mathematically, Euclidean distance is nothing but the root of square difference between the coordinates of two objects is nothing but Euclidean distance. So if you see the formula, you will easily understand. Suppose I have two data points x1 and x1 y1. So I have this data point and I have this data point. This data point have a coordinate x1 y1 and this data point having coordinate x2 and y2. Okay, so now I want to find the distance between these two data points. So I want to find the value of d. So to find the value of d, I'm using the Euclidean distance formula, which is square root of x2 minus x2 minus x1 whole square plus y2 minus y1 whole square. So this will become my Euclidean distance formula. Yeah. So we'll see with the example that how Euclidean distance works. Suppose I have two data points. A is consisting of 2, 5. Coordinates are 2, 5, and for B coordinates are 6 and 9. Now I want to apply Euclidean distance and I want to find the distance between these two data points. So just a simple thing. My formula is square root of x2 minus x1 whole square plus y2 minus y1 whole square. Fine. Now I'll keep the value in the formula and get the result. My A, in the case of A, the value is 2 and 5, and for B it is 6 and 9. So x2 minus x1 is nothing but 6 minus 2 whole square plus 9 minus 5 whole square. So we have written and square root of this. When we'll solve this, we will get the result, which is 16 plus 16, it is 32. And when we'll find the square root of this, we'll get the value, which is 5.66. So this is the easiest method to find the distance between the two points, which is called Euclidean distance, and it is used to find the ordinary distance between the data points. So I hope it is clear to you. The next one is Manhattan distance. So if you want to find the absolute difference between the data points or the coordinates, we will use the absolute difference, or we can say Manhattan distance. Fine. So we'll see here we have in a plane we have two coordinates. We have coordinate x1 y1, which is representing by p, and at q we are having two coordinates x2 and y2, and I want to find the Manhattan distance between these two, or I can say I want to find the absolute difference between these two. So just we'll use this formula, x1 minus absolute, or we can say magnitude of x1 minus x2 plus magnitude of y1 minus y2. So this is my Manhattan distance formula. Okay, so just see here I have these two data points, which is represented through this black dots. I have this data point and I have this data points. And now I want to find out the distance between these two data points. So this red line is representing the absolute difference between these two data points. Okay, so this absolute difference is nothing but we'll call it as Manhattan distance between the points. So to calculate the Manhattan distance between these two data points, we'll have a simple formula. To take an example here, we have coordinates p, we have p and q, and the value of p is 3 and 7, and for q it is 9 and 2. I'll keep the value in the formula. So my formula is what? x2 minus x1, absolute value of x2 minus x1 plus absolute value of y2 minus y1. So my x2 is what? 9 here, and my x1 is 3, so 9 minus 3 plus we are writing here y2 minus y1, which is 2 minus 7. So it will be 2 minus 7, and when we'll solve this one, so magnitude of this is what? 6, and 2 minus 7 it will be 5, as it is a magnitude, or we can say absolute value of minus 5, it will become 5. So it is 6 plus 5, which is 11. So this is my Manhattan distance, and Manhattan distance is nothing but if I want to find the absolute difference between these two data points or coordinates, we'll go with the Manhattan distance. I hope it is clear. The next is Jagged index. So Jagged index is nothing but it's a distance measure, the similarity of two data set items as the intersection of those items divided by the union of the data items. So if I want to find the Jagged index, I have to use the intersection of those items should be divided by the union of the data items. We'll see the example, it will be clear to you. First of all, you should know the difference between intersection as well as union. So I have said one set which is A, another set is B. So intersection is nothing but the common between A and B is called intersection, and this is the symbol for intersection. And when I'm saying union, union is nothing but all the value of set A and all the value of set B is called union. So this is called A union B. And when I'm finding the Jagged index is nothing but absolute value of A intersection B divided by A union B. So this is my Jagged index. So this is the formula for Jagged index. I hope it is clear to you. So when we are taking one example here, I have two sets. One A is consisting 1, 2, 3. B is consisting 2, 3, 4, 5. Now I have to find A union B as well as A intersection B. So what is A intersection B? A intersection B is nothing but common between A and B. So 2 and 3 is common. So my A intersection B value is 2 and 3. When I'm talking about A union B is nothing but all the value of set A as well as all the value of set B. But there will be no repetition. So A union B will become 1, 2, 3, 4, 5. So I have these values. So in A intersection B is having how many values? 2. So it will be 2. And A union B is having how many values? 5. So 2 divided by 5. So my Jacob index is nothing but 0.4. Clear? Now the next is Minkowski distance. So Minkowski distance is nothing but we can say it's a generalized form of Euclidean distance and Manhattan distance. So whenever we are having n-dimensional space and I want to find the Minkowski distance, then how it will work. So see, I have a data points which is x1 to xn and I'm considering two data points which is p1. P1 is consisting of x1 to xn and p2 is considering y1 to yn. And now I want to find out Minkowski distance between p1 and p2. Then my formula will be p the root of x1 minus y1 to the power p plus x2 minus y to the power p. In the same way till xn minus yn to the power p. So what is exactly p here? P is nothing but my parameter here. So if p value I'm considering as 2, Minkowski distance will work as an Euclidean distance. So your formula will become like Euclidean distance when my p is 2. If you remember Euclidean distance formula, you will understand that how it is. So if p is 2, it is same like Euclidean distance. If my p is 1, Minkowski distance will work as a Manhattan distance. Okay. So if it's my advice. So first you listen Manhattan and Euclidean distance, then easily you can understand that how Minkowski works. Fine, so this is the formula for Minkowski. Now we'll see how it works. We'll take a simple example. I'm considering p value here 3. So we say Manhattan Minkowski distance with parameter 3 and I have two data points x and y which is consisting of value 1, 2, 3 and y is consisting 403 and I want to calculate the Minkowski distance with p equal to 3. So if I want to do this, then I have to find the absolute difference between the data points, between the x1 and y1. So it is my 1, 2, 3 and this is 403. So absolute difference between 1 minus 4 to the magnitude of 3 because my parameter value is what here? 3. So when I will calculate this, it will become 27 and as we are finding the absolute value, my negative negation will not work here. So it will become 27. In the same way, I'll do for x2 and y2. So x2 is 2 and y2 is 0. So 2 minus 0 and with magnitude of 3 and we'll calculate, we'll get the result 8. In the same way, we'll do for x3 and y3, we'll get the 0. And finally, we'll sum all these values as per our formula. So it will be 27 plus 8 plus 0, it will become 35. And finally, we'll take pth root as per our formula. So if you remember the formula, the same thing we are doing here. Just we are keeping all the values in the formula and we are getting the result. So what is my p here? P is 3, so it will be what? Whatever value we are having, just square root of that, it will become 1 by 3 and final result is 3.27 when my P value is 3. So same way when I'm taking P value as 1, it will work as Manhattan distance. So when I'm taking P value 1, so just I have to do what? X1 minus y1 plus x2 minus y2 and x3 minus y3 and we'll get the final result. So my when I'm keeping p value 1, it will become Manhattan distance. When I'm taking p value 2, it will behave like a Euclidean distance. Okay, so when I'm taking p value 2, what will be the formula? This was the formula of Euclidean distance. Again, I'll take the same data point x1 minus y1 plus x2 minus y2 whole square plus x3 minus y3 whole square and when we will solve this, we'll get the final outcome. So this is your Minkowski distance. So just I'll summarize here. When I'm taking p value as 1 in Minkowski distance, then it will behave like a Manhattan distance and it is used to find the sum of absolute difference. When I'm taking p value 2, it will be like a Euclidean distance and it is nothing but root of the sum of square difference. And Minkowski distance in that p can be of any positive integer. If it is greater than Two, it could be any positive integer, and it is generalization encompassing both Manhattan and the Euclidean distance. So this is all about Minkowski distance. And the last one we are having here, cosine index. So what exactly the cosine index is? Cosine index measure is for clustering, determine the cosine of angle between two vectors given by the formula. So I want to find out the angle between two vectors. So I have two vectors given here. Vector 1 is consisting of two coordinate x1 and y1, other vector b which is consisting of data point x2 and y2, and I want to find the angle between these two data points. So I want to find the value of theta. So if I want to find the value of theta, I am using the cosine index here. And the formula for finding the cosine index is nothing but similarity. I want to find out between a and b, which is representing by cos theta equal to product of a and product of b divided by magnitude of a and magnitude of b. Okay, so we'll use this formula and we'll get the final outcome. So I have, suppose I'm taking the value of A, which is 1, 2, 3, and value of B, which is 4, 5, 6. So if I first I will find the product of A and B, because as per the formula I have to find product of A and B. So when I'll find the product of A and B, it will be 1 into 4 plus 2 into 5 plus 3 into 6. And my final outcome will be 32. The same way I have to find the magnitude of A and B. So if I'm finding the magnitude of A, it is nothing but square root of all the values belongs to A. So it will be 1 square plus 2 square plus 3 square. So result will be root of 14. Same way I'll find the magnitude of B, which is 4 square plus 5 square plus 6 square and root of 4. We'll get the final result, which is 77. Now I'll keep all these values in the formula and I'll get the final outcome. So my product of A and B is 32, magnitude of A is 14, magnitude of B is 77, and my final result, when I'm keeping all the values in the formula, my final outcome will be 0.97. So this is about cosine similarity. Now, what will interpret with the cosine similarity when I'm getting certain result? When I'm getting such results, what I can predict with that, what I can interpret with that. So whenever I'm talking about cosine similarity, the value which will get through that, it will range between -1 to +1. So if it is 1, it indicates that both the vectors are identical, or we can say the both points are in the same direction. If value is 0, it means vectors are orthogonal, means they form a 90-degree angle with each other. And if the value is -1, cosine similarity measure is -1, which is representing that it is just diametrically opposite to each other. They are in, both the points are in opposite direction. Okay. So our result is 0.97 in this example. So we can say that both the data points are in the same direction. So this is all about cosine similarity. Okay, so cosine similarity, if I'm saying that the use case of cosine similarity, if I want to find the similarity between the text, I have two documents, and I want to find the similarity between two documents. Suppose I have a summary of a book and I'm giving the same book to the LLM model and I'm asking a summary of that model through LLM and a summary which is written by author, and I want to know how much similar both the summary is. I can use the concept of cosine similarity. So I'm suggesting you to once try with the simple example that how to calculate the cosine similarity between two sentences at least. So try to solve this example. You will get an idea that how the cosine similarity works. So here there are two documents. One document is consisting of I love machine learning and another document is consisting of machine learning is great. Now I want to see how much similarity between these two data points or these two documents. So we are applying here cosine similarity. So I'm suggesting you to solve this one example using the cosine similarity formula. So this is all about the similarity measures. So we have discussed in this lecture, we have discussed first about the clustering, and then we have discussed how similarity measures are important whenever we are dealing with the clustering algorithm. So I've discussed 5 different similarity measures, and we have discussed this example of every similarity measure. So this is all about the today's class. I hope you have enjoyed. Thank you.